So today we're going to be talking about soil formation. And to do that, we first need to talk about rock weathering, how rocks are weathered, because pieces of rock from this weathering process are going to end up being part of the soil. In order to talk about rock weathering, we first need to make sure that we distinguish the difference between weathering and erosion. So weathering is the disintegration of rock near the surface. So the actual physical or chemical breaking up of the rock into smaller pieces. Erosion, on the other hand, could be of rock pieces or soil. And erosion is where those broken rocks and sediments or even soil get picked up and moved to another place by ice, wind, or water. So weathering, breaking it up, erosion, moving it. When we talk about weathering, it's actually broken up into two main categories, mechanical weathering and then chemical weathering. Mechanical weathering can then be broken up further into different types of mechanical weathering. The first type of mechanical weathering is frost action, which you can see in this picture here. So in frost action, water will actually get into little cracks in the rock. When that water gets into those cracks and it gets cold, the water freezes, and as it freezes, it expands. When this happens over and over and over and over again, that constant water getting into the cracks, freezing, expanding, can then deepen the cracks. And can start off as just a little tiny crack, can end up being big cracks, like in this rock over here. Another type of mechanical weathering is a little bit similar to this, but it's actually root wedging. So this is where a tree, a small little sapling, will start growing in a small crack of the rock. And as that plant grows in that crack, the roots will actually push against the rock, and the roots will go deeper into the rock and kind of wedge it apart, crack it apart. And this can be just smaller plants breaking up the rock in this way, opening up joints in the rock, or you can have a large tree, like in this case, opening up this deep crack here. A third type of mechanical weathering is called thermal expansion. So warmer things expand when they heat up, and a rigid surface like rock, when it expands and heats up and then cools down and contracts, it can actually weaken parts of the rock. So if you've ever driven across a bridge, you might have seen these expansion joints in the bridge that you've maybe driven across that are sort of like cut into the bridge, and then they're overlapping pieces of metal. And what this is doing is it's actually allowing that concrete bridge to expand and contract, so that when it is cooling down and contracting, those joints are moving closer together, and then when it's expanding, they're moving farther apart. Since rocks don't have these expansion joints, when they expand and then contract, you get these cracks forming on the surface of the rock, and then over time those cracks can deepen and parts of the rock can actually break away, like in this case. And then the last type of mechanical weathering is actually called salt wedging, and this is where grains of salt are going to work their way into cracks in the rock and then actually abrade away at the rock. So if we go back, our four types of mechanical weathering so far are frost action, right here, thermal expansion, right here, root wedging, right here, and then salt wedging here. There are a couple other types of mechanical weathering, and those are unloading and exfoliation, and then abrasion. So unloading and exfoliation is right here. So what's happening here is that you have this yellow rock right here buried underneath a bunch of other rock on top. And over time, this rock on top can actually get worn away. So you start off with this rock sort of buried. You have this rock on top that it is actually exerting pressure down on that rock on the bottom. Over time, that rock on top gets worn away. So then you have this rock on the bottom that gets exposed. And when this rock on the bottom gets exposed, all of that pressure that was being exerted on it this way is now gone. So when that pressure is released from this rock on the bottom, right, it starts to expand outward, sort of this curved pattern because of that release of pressure. And as it expands, right, expansion of rock is going to cause cracking, and that cracking is going to create these sort of curved sheets in the rock. Right? And those curved sheets are called exfoliation slabs. Right? So you can actually see this down here in Yosemite National Park, and then over here at this Enchanted Rock State Park in Texas. Right? So the unloading of that pressure from that top layers of rock being removed causes the expansion of this lower rock, and then that expansion causes the cracking of the rock in these curved exfoliating sheets or slabs. Abrasion can be done by water or wind. If you think about someone being really abrasive, they kind of rub you the wrong way. So abrasion is where rock gets rubbed by water or wind, and that rubbing of the rock by the water or wind is going to slowly take away some of those sharper edges, wearing it away. So you start off with these kind of angular pieces of rock over here, right, and those angular pieces get worn away by the water and wind rubbing against it, and slowly you get sort of more rounded rocks going in this direction. And it's hard to believe that wind can actually do this, but if you think about over time, the wind or water just constantly moving past these rocks, you can get actually pretty cool formations like this. Right. So our last two pieces of mechanical weathering, unloading and exfoliation, which are tied together, and then abrasion. So mechanical weathering as a whole is disintegration of the rock into smaller and smaller fragments by physical means. In contrast, chemical weathering is going to be where rainwater reacts with the mineral grains in the rock to form new minerals like clays and or soluble salts, and these reactions can occur particularly when the water is slightly acidic. So first up is solution chemical weathering. Looks like this. In solution chemical weathering, minerals in the rock are actually going to dissolve directly into the water. So in particular, limestone, like in this limestone cave, is weathered by rainwater containing dissolved CO2, which can turn into carbonic acid. That carbonic acid seeps into cracks and cavities, and then will actually dissolve away some of that lime. So you can think of this as sort of minerals that are contained within the rock reacting with the rainwater by dissolving into the rainwater, and then they're then being taken out of the rock itself. This can happen with halite, rocks with large amounts of halite, so like down here. If you have this bedrock with a large amount of halite, halite is rock salt. So if you get water seeping into this bedrock with halite, the salt is actually going to dissolve out of the rock into solution chemical weathering, and that's going to cause holes and weakness in this bedrock, like here, and then some of this earth can then seep into those holes, right? And then that can actually result in sinkholes. Hydrolysis is also water reacting with minerals in the rock, but what's happening here is you're not having minerals come out into solution. Water is actually combining with substances in the rocks to form new types of substances like clays, which are softer than the original rock types. So here you have feldspar, and when water reacts with the feldspar, you're going to get the creation of kaolinite clay. And kaolinite clay is going to be softer than the original feldspar. Last up for chemical weathering is oxidation. In oxidation, you're going to get the breakdown of the rock by a reaction between oxygen and water. So these are with iron-rich rocks. So the oxygen and then the iron in the rocks are going to react in the presence of water, and that gives this iron rock like a rust-colored, weathered surface. If you think about if you leave like an old car out in your yard, it's going to get really rusty, and then as it gets really rusty, those rusted parts are weaker and they disintegrate much more quickly. So oxidation, this reaction of oxygen and water with the iron in rocks, then makes the rock weaker and able to weather away. So acid precipitation or acid rain is where sulfur dioxide, so right here, or nitrous oxide are going to react with water vapor in the atmosphere to form sulfuric acid and nitric acid. Sulfuric acid and nitric acid in acid rain are going to result in more rapid degradation of limestone, marble structures. It's going to accelerate this chemical weathering process. It's just more able to leach these minerals from the rocks or even actually soil. So remember that erosion is where all of that broken rock and sediment from weathering actually gets picked up and moved to another place. And the means of this movement can be done by ice, wind, or water. Right, so you can see here's a river sort of carving out a valley because that river is abrading the sides of the banks and slowly wearing them away. So it's actually we're having weathering and erosion here together, the actual abrasive nature of the river, but then the river is also taking those broken rocks and pieces from the water weathering and carrying them away, resulting in erosion. Right. So here again, you have the abrasive weathering action of the wave beating up against the rock, but the wave is also carrying away those pieces. So you can have a wave be the means of both weathering and erosion. Here you can see the wind blowing away topsoil, right? So it's abrading that topsoil. That's the weathering process. It actually carrying those pieces away is the erosion process. Right? This glacier rubbing against a rock, if it abrades that rock, that's the weathering process, so the actual physical breaking up of the rock. But then that glacier actually moving the rock pieces away is the erosion process. And then landslides are going to be a much more extreme version of this erosion process. So here are just some really extreme versions of wind erosion. They can actually form pretty magnificent structures. So if you've ever been to Arches National Park in Utah, here's some examples of water erosion. So this was done by a river, this was done by waves, this was actually done by rainfall, dripping. Here are some other examples of wave erosion. So again, in these cases, wind, water, waves, them actually abrading the rock, that's the mechanical weathering part. But the waves and wind and rivers carrying those particles away, that's the erosion part. Right, so we had to understand weathering in order to sort of think about how soil is formed. But before we talk about how soil is formed, we need to talk about why soil is actually important. One of the reasons soil is important is that it supports plants. So it actually gives plants a place to grow, to anchor. Another important piece of soil is it prevents erosion. So having well-maintained soil and plants will prevent that soil from eroding away. Soil holds onto water, and that is important in maintaining our water cycle, and soil holds onto nutrients. So a key part of cycling matter through ecosystems. So how is soil actually made? And there's a couple different components to this. The first component is the actual weathering process. So here you can see you have some parent material. So parent material is the actual rock material. And that parent material is going to get weathered away by physical means, so mechanical weathering, and chemical weathering, chemical means. The mechanical and chemical weathering of that parent material is going to release minerals and nutrients that are important for soil formation, and also particles like silt, sand, quartz, etc. So these the silica, the minerals, the nutrients, and then the actual particles themselves, the silt and the sand, are important components of the end soil. So you can see another picture of that here. So you start out with this bedrock right here, and that bedrock is going to get disintegrated by chemical and physical means, and so you get the release of minerals and then particles, and then you also have organic matter like this start to develop. If you remember our talk about succession, so that organic matter is going to start creeping into the bedrock, growing on top of the disintegrated rock, and then that organic matter is going to decompose and also create this sort of nutrient-rich decomposition layer of the soil. So you have soil creation coming from below, from the bedrock, which is releasing minerals and particles, and then you have soil creation coming from above by the decomposition of this plant matter. So the bedrock is adding in minerals and particles, and then this decomposition of the plant matter that's able to grow initially and then continue to grow is going to add in this decomposed nutrients and also some detritus that is breaking down. And as this process continues, you get a deeper profile, deeper soil. So here's another way of looking at this. There's a bunch of different components that are going into the soil here. You've got the mineral particles from the parent materials. You've got this sort of detritus, decaying, decomposed plant matter. And then you have this detritus food web that is helping this decomposition process to happen. This process of weathering and then breaking down of organic matter is going to give the soil various properties, and there are going to be 5 main factors that determine soil properties. And soil properties can include like texture, cation exchange, base saturation, which are things that we'll talk about next time. So the 5 factors that can determine the soil property are: 1, the parent material itself. Right, so what was the initial rock that was broken down, the underlying rock material that is becoming soil? So for example, if you have a soil starting out from quartz, you're going to end up with a nutrient poor soil. If you have a soil starting from the parent material, the rock calcium carbonate, you're going to end up with a soil that has lots of calcium. So the parent material, the type of rock that is sort of kicking off this process, is being weathered away. That's going to determine aspects of the end soil. Another factor that can determine soil properties is the climate. So if you have below freezing temperatures, that's not going to allow for much decomposition, so you're not going to get very many nutrients in the soil. If you have something like the tropical rainforest, you're going to get development really accelerated. So the type of vegetation is determined by the climate. That's going to determine the type of detritus. Also, if you have a lot of rainfall, you can get a lot of leaching from the soil. So a lot of rainfall, you can have sort of percolating through the soil and pulling nutrients and minerals out of the soil. So the temperature can determine how much decomposition you have. The amount of rainfall can determine how much leaching or pulling of minerals and nutrients out of the soil you can have. Next up is topography. And we sort of saw this when we were out walking in the woods with the pine forest. If it's the surface slope and a range of the landscape. So steep slopes, like we saw out in the woods, are going to be more subject to erosion. So you're going to get a thinner soil layer on the steep slope, and you're going to get more soil accumulating at the bottom of the slope. So the steep slope is going to determine sort of what can grow there. Like we saw that pine trees are okay with a thinner soil layer, so they were growing more on that steep slope than like the hardwoods that need a deeper soil that would be more common at a lower slope or at the bottom. Another factor that's going to determine soil properties are the organisms that live in the soil, or the plants that are growing in the soil. So plants are going to be removing nutrients from the soil. Some of them are excreting organic acids. You also have animals that are burrowing into the soil, mixing it, breaking detritus down. There are some plants like legumes that can add nitrogen to the soil. So the types of organisms that are either growing in the soil, like the plants, or the animals that are breaking down the detritus, burrowing in the soil, that can determine various properties of the soil. And then the last factor that determines soil properties is time. Right, so the amount of time that the soil has to develop. Right, so if you have generally longer amount of time, you're going to have a deeper soil profile, but then you also have time for that soil to sort of be leached or by rainfall. So you have to kind of have this balancing act of amount of time for the parent material to weather down, for the decomposition process to sort of build up that organic matter in the soil, but really old soils could also be more leached. So it's this balancing act, and that's probably going to depend on kind of what climate it's in, what types of organisms are there. That's it for now. So next time we're going to talk more about soil characteristics, which are kind of determined by some of these factors that determine soil properties.